Okay, and welcome to this one. Again, we're talking about measuring motion still. This is page 13, and we're going to talk about just the slope of the line. And what does the slope of the line mean? So again, let's read through our questions. What does the graph show when it is a solid straight line? What would you expect to see when two cars are moving at a constant rate and one is faster than the other? The next one is, what would you expect to see when two cars are moving at a constant rate, but one has a head start? The next question, what would you expect to see when two cars are 10 centimeters apart and moving at a constant rate towards each other? And then the last one is, what is the bottom graph illustrating? So let's just go back up here and get started. So the first one says that remember that the speed of the object is equal to the slope. So the speed is equal to the slope. The steeper, the faster. We just wrote that on our last video if according to where you're at watching these. For example, the graph below shows two cars that are traveling at two different constant speeds. Now, we've probably did labs in which we talk about the constant speed and the fact that if the line is straight, not curved like a parabola, then it's going at a constant speed. So the slope of these lines of these graphs indicate the speed of the car. The graph of the motion of a fast-moving car is steeper than that of a slow-moving car. The fact that these graphs are straight line indicates that they're moving at a constant speed. Okay? On a graph of a distance time graph, the motion of an object that is moving with a variable speed will have a curved line. Now, this, what we mean by variable, would be that something that is like speeding up or slowing down. So this might be you as you travel through town, okay? Because you're going to be speeding up and slowing down. Now, that would not be like our car going down a ramp in which it's going at still accelerating or decelerating at a constant rate, okay? So the next one says that even if the object speed is changing, you can use a graph. And then we can find what's called the average speed. Remember, the average speed is equal to the total distance divided by total time. Total distance divided by total time. Okay? So let's go ahead and get started here. So, first one. What does the graph show when it is a solid, straight line? Okay? And so, again, a straight line indicates it's moving at a constant rate. Okay, and again, if I didn't tell you this before, be sure if you're trying to keep up with me, hit the pause button. That's the nice thing about a video versus us doing it in class, is you can hit that stop button. I know some of you write faster, some of you write slow. That's okay, that's not a problem. Just hit the pause button. Okay, next one. What would you expect to see when two cars are moving at a constant rate, okay, but one is faster than the other? Okay, so that might be an example here, slow moving, fast moving. So hopefully you see that one line will be steeper than the other. Okay, and in particular, the faster is steeper, right? So the next one, what would you expect to see? This one's kind of tricky. When two cars are moving at a constant rate, but one has a head start. So what we mean by head start is from our frame of reference that we're looking at, or our starting point would be our frame of reference. One has a head start. So if I'm looking at, let's say, this graph right here, or this one, either one. So I'm going to use this one to illustrate number 3. on there. So two cars are moving at a constant rate, but one has a head start on that. And so since one has a head start, that means at 0 time, the distance that it is already. Now, if I'm going to show they're moving at the same rate, one just has a head start. Okay? And hopefully that should make sense. They're going to be parallel and they're never going to cross. Okay? Now, it doesn't necessarily tell me that they are going at the same constant rate, just that one has a head start. So if they're not going at the same rate, okay, maybe car B started first, but is going slower, and then maybe our graph would look like this, in which what we could see is that at 2 seconds, this car would overtake that car, okay? Or, of course, I could also draw it. I'm running out of pencils here, pens. I could also say that this one started here, but it's going a lot faster. And then in this case, they're never going to cross. So if you are comfortable with math and you've had Algebra 1, maybe Algebra 2, and you have graphed what we call systems of equations by graphing and finding out where they cross, this would be a good example of where you have a point, okay? In this case, 2 seconds, they would cross 60 meters, or 60 meters from the start. This one would be your parallel lines in which there is no solution. They're never going to cross. And then this one, again, would be if we're only dealing with this case, again, there's not going to be any crossing point. They're never going to hit because this one started earlier and is going faster. So that one would also never. Now, if you were doing it in algebra class, you would still have it coming on down into the negative region. So you would have a point of intersection back there. But that's another story. So that part may not make any sense to you. Okay. So I'm going to put illustrated above. Okay. Now then the next one says, what would you expect if the two cars are 10 meters apart and they're moving towards each other? So here would be our graph, and I'm going to change that just so I can see it a little bit better. So here's my graph. One's here, one's here. They're 20 meters apart, and they're moving at the constant rate towards each other. So this one has a slope of positive 10, up 10 over 1. So this one would be down 10 over 1. And so it would look maybe like that. You see what I'm saying? So they're starting apart, they're moving, but the slope of this line and the slope of this line should be the same. Okay? And this one would have made more sense if I'd have started them at maybe 80. So you could have actually seen the line. So if I had started them at 80 here, and then I would have had a graph looking like this coming down. And again, those two graphs should have looked the same. Okay? So again, illustrated above. Okay? So be sure you draw that in, or you have to write an answer. Okay, the next one is, what is the bottom graph illustrating? And again, it is illustrating that the speed is changing. And if we wanted to calculate the average speed, again, it says the total distance. So when I look at it, it started at 0. I went a total of 60 meters and a total time of 5 seconds. And so in this case, 12 meters per second. Okay? So hopefully that makes sense to you. Again, what does this mean on there is basically I would say that graphs can be used to compare or illustrate the motion of more than one object. Okay, and just so that we can, again, do a comparison of those. Okay, that sounds good on that one. We'll talk to you later.